All right, guys, let's do number 60 here. A rock is dropped from the rest onto a well. The sound of the splash is heard 2.4 seconds after the rock is released from the rest. How far below the top of the well is the surface of the water, the speed of the sound in the air? Okay, so they're taking that into account. I mean, of course, you have to, because you don't hear the rock from the splashing the water the instant it touches the water. You hear the propagation of the air, which vibrates, folks. That's what it is. And the vibration between the crest or that little amplitudes or whatever between those same points is going to be 3.336 meters per second. So I actually like this problem, and it's pretty straightforward. It's not really, I don't know why it's red, but you know, but we're not here to memorize, folks. So you drop the water. So what is actually going on? A water is dropped from the well. So a rock is being dropped. And what we wanted to find is the height of the well. So we want to find this height, which I'm going to call capital, or I'm going to call it little h. And the splash is heard 2.4 seconds. So what this means, folks, is that this is going to be the t-axis, this is going to be the y-axis, and the rock is being dropped. So once the rock is being dropped, it's going to have its motion. It's going to start from initial velocity at 0, and it's going to drop towards a specific time. So that specific time I'm going to call T1, I guess. In fact, I'm just going to call it T1 just to make it easier. And after T1, the sound of the air. So it's going to drop. The rock is going to drop. It's going to hit the water. And then that water, that propagation is going to travel at the velocity at 303.6 meters per second. That is going to be the speed of the air, in which is going to float back up, and then you're going to hear the sound. So let me put the variables, folks. And you hear it 2.4 seconds after the rock is being raised. So that's another way of saying, which I'm going to call that T2. So T2 is going to be 2.40 seconds. The speed of the air is going to be 303.6 meters per second. And of course, we're taking into account of gravity, which is 9.8 meters per second square. So a rock is going to be dropped from the well. It's going to hit the water, and then it's going to travel at. In fact, the slope would be very, very slanted, because that is pretty. It would be very steep slope, because that is a high speed. So it's gonna. I'm not gonna draw it that steep though. I'm just gonna draw it very like that. And that's when you hear it. So this is going to be. So that's going to be T2. And notice, folks, that all I'm doing is getting myself set up. And that's going to be H. All right, folks. Now now since we got the visual presentation out of the way, let's actually solve this. Let's see what they're asking. The sound of this splash is heard 2.4 seconds. So I already wrote that down after. Okay. How far below the top of the well of the surface of the water? Of course, they're going to ask for H. Okay. So what is H? So this equation for the blue graph is going to be y equals some initial position H being drawn, which is going to be 0, minus g over 2t squared. specifically t being from t to t1. After that, the position for the air, and this is going to be a different graph here. So this is going to be y1 and y2. It's really just going to be the constant velocity times the time it takes. But the time is going to be the interval between after t I'm going to put a plus. Would that work? No, actually, no, it wouldn't work. Oh my god, I'm a dumbass. Okay, t minus, I've done this so many times and then I forget. Okay, t minus t1. Yeah, so that's the time interval after t1. So, and that t would have to be after between t1 and t2. So that's your equation, folks. So, and 2y2 would have to be the final for this to be t1. So that's going to be this equation that we're going to set up using from this other equation. And from the first one, we're going to let the y be 0 at h minus g over 2 at specifically t1 square. And actually, that's actually t2, by the way. And that's t1. So I hope you notice, folks, that I really do not have any of these memorized. I am figuring them out from scratch. And what they're asking for is, we don't know the time it takes. Oh, that's t2 minus t1. So there you go. So that's t2 minus t1, folks. That's the, okay. We know what t2 is. We don't know what t1 is, but we can solve for that. But before we do this, let's be smart about this, because I remember this. I did solve this before. I pressed the record button, and that was like a few days ago. And I remember it was a little trick that I did, because the algebra can get a mess. So let's kind of, so let's think about this. What we ultimately want is to solve for h. We could solve for any of the variables, but and the only two unknowns that we have is t1. We want to be able to manipulate this in such a way to make this easier for us. So what we could do is we could oh, actually, I don't know. Oh yeah, I do know. Okay, see, I've already thought of this. I'm going to take the first equation. I'm going to solve for h, and we're going to have a quadratic formula, but that's okay. And I'm going to let this equal to be v naught t2 minus t1. We know what t2 is. And the reason for that is because I want this to be a nice little simple quadratic formula so that we can solve for one of the variables so we can get the other one. So what I'm going to solve for is specifically t1, the time it takes for the rock to hit the water. So let's do that. Let's move the v naught t and rearrange this. So I'm going to say this is going to be t1 square added to v naught t2 minus v naught t2. I'm going to move this on the side. And I'm going to take the minus and then add it on this side. So plus v naught t1. Beautiful. And we're going to let this equation be 0. Right off the bat, folks, this is already solved right there. It's pretty straightforward. Use the quadratic formula to solve for t1. And once you put this in the calculator, you should get the t1, and I did verify this. T1 here is going to be, what was it? I stored that now. 2.32 seconds. So that's the time it takes for it to hit the water. And then after that, it's going to travel this interval back to its original height. So what is it asking? Oh yeah, what is the... I forgot what the question is asking for. It's a little hard to like concentrate when like I'm having going back and forth between the calculator and this and talking at the same time. So so once you solve for this, then you can take gt over 2 of that thing square, and then you can get the height. So once you do that, let me get that right now. G over 2t squared store alpha h. And I did confirm this. The height here is going to be 26.4. I guess we'll round out to 1 meters. So that's part A. Part B, if the travel time for the sound is ignored, what percentage error is introduced into the depth of the calculator of the well? So that's another way of saying if the well is in that specific height, which is 26.4 meters, then what would the time be if this was ignored? Like, what would you calculate? And what error is that? So that's going to be 2 over g, the square root of 2h over g would be the time if air resistance would be ignored. So let's find this. So I'm going to pull that in there. And I got 2.32 seconds is what I ended up getting, folks. So as opposed to, what the fuck? Oh, of course. Wait, let me think about this. It's asking for the age. Okay. I got a little mixed up here. If the sound is ignored, what would the h be? Okay, what would the h be? So I got the same thing, which makes sense. But so let's just say that, what would this value be specifically at T2? So G over 2, and did I store this? Yeah, T2 is 2.4. Okay, so G over 2 times T square. So I got the value. So if you were to get that, you would get the height of 28.22 meters as opposed to 26.41. So let's take the lowest value divided by its highest value. So let's take the lowest value, which is the highest value, which is 28.22, divided by its lowest value, multiplied by 100, make it a percent there. So that would be maybe, and I'm going to take 100 minus that piece. However you guys want to rewrite this, either be 93. So I'm going to say 4.61%. I think that's what they call error. I'm not 100% sure. I have to look in the answer in the back of the book. But it's about 6.41%. Maybe. Maybe the answer is not going to match, but actually, let me pull that up. Okay. No, the answer matches. It sort of matches. I think I like to put the exact values in the calculator when I do my problems. But anyways, folks, that was it. I hope this was easy for you guys. I mean, I made a few mistakes, but that's all right. I corrected them. And you guys can, I hope this really helps you guys. And I want to emphasize the